This video introduces the usage of FAIRINO Robot as the Modbus TCP Master. First, let's move on to coding and create a new program. Open the Modbus TCP Settings interface, select Master Settings. Add a master station. The robot can support up to 8 master stations for communication simultaneously with the corresponding external slave stations, and can support up to 128 registers at most. Set the master station name in the name column. The slave IP, port number, station number, communication cycle, etc. need to be modified according to the external slave device. In this video, we use the MB slave software to simulate the external slave station devices. Open MB slave, click Connection and select Modbus TCP IP. Select the IP address of the computer's Ethernet port. Return to the robot Modbus TCP settings interface and set the master registers. Add 4 master station registers. Set to DI and to DO. Change the address numbers to 1 to 4 respectively. Modify the register name accordingly. The flashing green light of the connection status indicates that the data type of the slave station does not match that of master station at this time. Now let's look at DI, DO read and write operations. Select Modbus command. Select master station, digital output. Choose register 3, write to 4 number of registers, and write 1 for register value. Click Write, Add. Find numeric input, choose register 1, number of registers, write 2. Assign the read DI values to the variables A, B. Save after adding query variable instruction. Select MBSoft1 and click Setup, Slave Definition. Set slave ID to 1. Select 1 for the function code. Set quantity 20. Create MBSoft2 with the function code to end quantity 20. Put MBSoft to address 1 to on. Back to the robot interface, and DI1, DI2 address value is 1. Run the program, DO1, DO2 address value becomes 1. In the robot program interface, variables A, B are displayed as 1 both. MBSoft1 address 1 to also becomes 1. Now let's look at the unsigned I, O, read and write operations. Add to I unsigned, O unsigned. The address numbers are set to 5 to 8, respectively. Modify the register name accordingly. Select Modbus command. Select master station and analog output. Select register 7, write to for the number of registers and 11, 12 for the value of registers. Find analog input, select register 5, write to for number of registers, add. Assign the values of readed AI to variables A, B. Save after adding query variable instruction. Select MBSoft1, select 3 for the function code, and set quantity to 20, click OK. Select MBSOP2, select 4 for the function code, and set quantity to 20, click OK. Write the MBSOP to address 5, 6 to 13, 14. Back to the robot interface. At this point AI5, AI6 address values are 13, 14. Running the program, 07, 08 address values become 11, 12. In the robot program interface variables A, B are displayed as 13, 14. Next, we look at the send I, O, read, and write operations. Add to I send and O send. Set the address numbers to 9 to 12, respectively. Modify the register name accordingly. Select Modbus command. Select the master station, analog output. Select register 11, write to 4 the number of registers, and write -21 to 4 registers value. Find analog input, select register 9, write to 4 number of registers, add. Assign the values of readed AI to variables A, B. Save after adding query variable instruction. Select MBSOP1, select 3 for the function code, and set quantity to 20, click OK. Select MBSOP2, select 4 for the function code, and set quantity to 20, click OK. Write -23, 44 MBSOP to address 9, 10. Back to the robot interface. At this point AI9, AI10 address values are -23, 4. Run the program, 011, 012 address values. In program interface, A, B are displayed as -23, 4. MBSOP1 address 11, 12 also becomes -21, 2. Next, we look at the float AI, O, read, and write operations. Add to I float, O float respectively. Note that float registers occupy 2 even addresses. Set the address numbers to 12, 14, 16, 18 respectively. Modify the register name accordingly. Select master station, analog output. Select register 16, write 1, 33.5. Click write, add. Select register 18, write 1, 34.5. Find analog input, select register 12, write to 4 number of registers. Assign the values of AI read to variables A, B. Save after adding query variable instruction. Select MBSOP1, select 3 for the function code. Select the address, right-click and select Format, Float ABCD. Select MBSOP2, select File for the function code. Select the address, right-click and select Format, float ABCD. Write -35.5, 36.5 for MBSoft to address 12, 14. Go back to the robot interface. At this point AI12, AI14, address values are -35.5, 36.5. Run the program, 016, 18 values become 33.5, 34.5. In the robot program interface, variables A, B are displayed as -35.5, 36.5. MBSoft 1 address 16, 18 also becomes 33.5, 34.5. At last, let's look at the use of waiting for digital input and analog input setup instructions. Add the DI and NI and send. Set the address numbers to 12, 13, respectively. Modify the register name accordingly. Choose Waiting for Digital Input setting and select Register 12. Set the waiting state to true and the timeout to 5000. Choose Waiting for Analog Input setting and select Register 13. Set wait state to greater than, register value to 1, timeout to 5000, click Add. Add the corresponding digital input and analog input instructions. Assign to variables A, B and add query instructions. The program logic is to print the variable if the input is satisfied within 5 seconds, otherwise the robot reports an error and stops. Select MBSoft 1, select 2 for the function code. Select MBSoft 2, select 4 for the function code. Write 1 for address 12. Write 2 for address 13. At this point DI12, AI13 address values are 1, 2. Run the program and look at the values of the variables A, B. That's all for the usage of FR Robot as Modbus TCP Master Station. Thanks for watching.